moving on to chapter 55, which is other equipment. So far we've done wiring systems, and we've done protected devices, and we've done switching devices and isolation devices. Chapter 55 just includes all the other little bits that we need to consider with selection and erection of electrical equipment. It's got a little scope section there. Says it specifies requirements and recommendations for the selection and erection of low voltage equipment not covered by other parts of the regulations except for part 7. So important to remember with regards to electrical equipment, such as appliances and things like that. All that's a requirement of BS 767 is, as we said back in part 1 and also a bit in part 3, is to ensure that we design a system and then we select electrical equipment to ensure that the environmental factors, the users, the building, remember all those external influences we talked about in chapter 52, flora, fauna, water, dust, things like that. We must make sure that the electrical equipment is designed and selected so its life will not diminish. When selecting a maintenance strategy for equipment to ensure its life does not diminish, then we have obviously batch testing as one of the primary ways to achieve that. There might be a need to go beyond the scope of batch testing, such as having your own fixed maintenance strategy, which can often be a lot more accurate and a lot more controllable. 551 then. So 551 is for low voltage generating sets. This section applies to low voltage and extra low voltage installations which incorporate generating sets intended to supply either continuously or occasionally all a part of the installation. So if you're having a low voltage generator in a temporary area for an event or something as a parallel supply, then that will be a constant supply. It applies here. But you may have it as a standby supply or as a backup supply. It could even be, as is mentioned here, requirements are included limit for installations with the following: supply to the installation which is not connected to a system for distribution of electricity to the public. So this could be its own supply to its own system. It's not a parallel, it's not a backup, it's a completely separate system. It could supply an installation as an alternative. It could supply an installation in parallel, and an appropriate combination of the above. So an example of a parallel low voltage generating set, you think of your typical solar photovoltaic. The solar panels are generator sets, and with the if we have the standard feed-in tariff kind of national, it's connected in parallel with the national grid. If you had, for example, instead a PV array that was connecting to a battery system, then that would be a source of generation going to a stored area, and then that actual battery system is another source of generation. So it's another source of generation. So you have to apply them twice there. All right, but it's determining which one is which. It does say further down in 551.1.1 what is considered as a generating set here in 551. So it could be a combustion engine, a turbine, electric motor, photovoltaic cell, electrochemical accumulator, or other suitable source. Okay, so there are a number of types of generating sets recognised. Generating sets with the following characteristics are considered: mains excited and separately excited synchronous generators, mains excited and self-excited asynchronous generators, and mains commutated and self-commutated static converters with or without bypass facilities. The following purposes is considered as to why we use these generating sets. So, permanent installations and temporary installations. Let's not forget that with regards to temporary installations, we have other standards such as BS 7909, which may have to come into play. Mobile equipment which is not connected to a permanent fixed installation. Some mobile transportable units will actually have a dedicated turbine on top, which may even utilise an IT system as a source of electricity and generation. And just apply to standard mobile units. General requirements then. The means of excitation and commutation shall be appropriate for the intended use of the generating set and the safety and proper functioning of other sources of supply, and it should not be impaired by the generating set. Now, I'm not going to go into all the details of how generators work. Obviously, if you need further information on that, then we can look into developing something with regards to how a commutator works and DC and AC and generation of power. That's not really in this. That's not really what we need to worry about. The prospective short circuit current and prospective earth fault current shall be assessed for each source of supply or combination of sources, which can operate independently of other sources or combinations. The short circuit rating of the protected devices within the installation and where appropriate connected to a system for distribution of electricity to the public shall not exceed for any of the intended methods of operation of the sources. Okay, also shall not be exceeded. So, I mean, we've covered this a few times now. The protection against overcurrent. The devices must be selected to tolerate the prospective fault currents that can occur. Now, obviously, when we have generation sources, we may have a varying fault current depending on the earthing effect and the sources of generation. 551.2.3. Where the generating set is intended to provide a supply to installation which is not connected to a system for distribution of electricity to the public, or to provide a supply as a switched alternative, the capacity and operating characteristics of the generating set shall be such that danger or damage to the equipment does not arise after the connection or disconnection or any intended load as a result of the deviation of the voltage or frequency from the intended operating range. So, if you think about your standard generator like this, it has the control assembly within it to actually ensure that it creates the same voltage and frequency as your parallel supply. But some generation sets obviously can differ. With photovoltaics, for example, every single array will achieve a different level of voltage and DC current depending on the angle and the orientation and the actual, the string that they all connected into and the array, and that's how you kind of build a network. But then you have the inverter, and it's the job of the inverter to then actually take that DC value, whatever the current and voltage is, and play with that and spit out a voltage that is useful for the electrical installation. We then have 551.3, which talks about the use of the protective measure of self or PELV. Additional requirements for that. If self or PELV systems are supplied by more than one source, the requirements of 414.3 shall apply to each source. So 414.3 is actually, back in Chapter 41, Protection Against Electric Shock, it's the self-PELV section. It's saying that it will be applicable for every single source of supply. 551.3.2. Where it is necessary to maintain the supply to an extra low voltage system following the loss of one or more sources of supply, each source of supply or combination of the supplies, which can operate independently of other sources or combination, will be capable of supplying the intended load of the extra low voltage system. Provision shall be made so that the loss of the low voltage supply to an extra low voltage source does not lead to a danger or damage to other extra low voltage equipment. Okay, so if you have a loss of the supply, that the independent source of generation for the extra low voltage shall be capable, and there'll be no risk with the loss of the low voltage system. Full protection. It will be provided for the installation in respect for each source of supply or combination of sources of supply that can operate independently of other sources and combination of sources. Okay, let's push on. It makes, it's standard full protection stuff. 551.4.3.2. Additional requirements for the installations where the generating set will provide a switched alternative to systems for distribution of electricity to the public. So this is a standby supply, such as could be a diesel-driven generator in a basement in a large building. You can have a UPS backup system. In these cases, protection by ADS shall not rely upon the connection to the earth point of the system of the distribution of electricity to the public when the generator is opened as a switched alternative to a TN system. So what we're saying is the actual normal imported supply, which is on a TN system, when we have the switch over to our standby supply, it will not rely on the effectiveness and integrity of that system. It will have its own means of achieving ADS. Then we have static converters mentioned. Where the fault protection for parts installation supplied by the static converter relies upon the automatic closure of the bypass switch and the operation of protected devices on the supply side of the bypass switch is not within the time required by 411, then we'll need to achieve supplementary bonding. Okay, between simultaneously accessible exposed conductive parts and extrinsic conductive parts on the load side of the static converter in accordance with 415.2. And again, the question with bonding, as we've mentioned in a few videos now, is it's always about making sure the value of voltage present in the fault condition does not exceed 50. So if you look at the formula there, it's Ohm's law with 50 volts. Where IA is the maximum earth fault current which can be supplied by the static converter when the bypass switch is closed. So the maximum permissible current that can occur, okay, 50 volts over that gives you your value of resistance, and if you have a value greater than that, you achieve supplementary bonding to bring the value below that. Okay, 551.4.4. This is additional requirements for protection by a automatic disconnection where the installation and generating set are not permanently fixed. So the generating sets are not intended to. They are intended to be moved to unspecified locations for temporary or short-term use. This is a mobile generator, really. They may be part of an installation which is subject to similar use. This regulation does not apply to permanent fixed installations. So, between separate items of equipment, protective conductors shall be provided which are part of a suitable cable that complies with Table 54.7. And all protective conductors shall comply with Chapter 54. Okay, we've just done that in the previous video. In the TNTT or IT system, every final circuit shall be provided with additional protection by means of an RCD having the characteristics specified in Regulation 415.1. So that's the RCD needed for additional protection, which is just I delta N 30 milliamp, really, isn't it? Protection against overcurrent. When overcurrent protection of the generating set is required, it shall be located as near as practicable to the generator terminals. Where the generating set is intended to operate in parallel with a system for distribution of electricity to the public, where two or more generating sets may operate in parallel, circulating harmonic currents shall be limited so that the thermal rating of the conductors is not exceeded. Now, if you remember back in part 4 when we looked at trying to remember the part now, it was chapter 43. We did a part and we talked about where we had two sources of supply, and we had to make sure that if we had one source and we had a link between neutral and earth, that the other source did not, so we didn't have the looping currents through that. This is what this is also suggesting. So if we have a generator supplying an installation with a fixed supply also, we need to make sure that if there's a link between neutral and earth on the public supply, so it's a TNCS system, that we don't have a pen conductor coming from our generated circuit. All right. Similarly, if we had two generators, we don't want that because we're going to have harmonic currents circulating between neutrals and earths. All right. Just going to overcurrent. The effects of circulating harmonic currents may be limited by one of the following: the selection of a generating set with compensated windings, suitable impedances in the connection to the generator starter points, provision of switches which interrupt the circulatory circuit but which are interlocked at all times for fault protection so it's not impaired, filtering equipment or other suitable means. 5516. Here we have installations where the generating set provides a supply as a switched alternative. So it's your backup generator. Okay, it's not an additional supply to support an increased demand. It's a replacement supply in a power loss scenario. So in this case, we need to make sure that there's no potential for one source of supply to jump on with the other. So if we have a public supply and there's a backup generator or a UPS bank of batteries, we need to make sure there's a proper switchover method that will recognise the loss of supply there and will then link over to the new supply. We can't have a system where it's just potentially that both are going to come on at once. So we need an electrical, mechanical, or electromechanical interlock between the operating mechanism or control circuit of the changeover switching device, a system of locks with a single transferable key, a 3-position break before make changeover switch, an automatic changeover switching device with a suitable interlock, or other means providing equivalent security of operation. It depends on what you're trying to switch. If it's obviously a static supply of immediate effect, we're going to look at this in a minute in the next video in chapter 56, where we talk about classifications, and we have no break, medium break, long break, kind of things like that. Depending on what the braking method or the time allowed is, will depend also on the switchover as well. Alright, let's move on from generators, I think, because it's going to be repeating itself now. Actually, no, before we leave generators, I would just like to look at 551.8, and that is stationary batteries. Stationary batteries shall be installed so they are accessible only to skilled or instructed persons. Okay, and then it says, battery connections shall have basic protection by insulation enclosures or shall be arranged so 2 bare conductive parts having between them a potential difference of 120 volts cannot inadvertently be touched simultaneously. That comes up in the exam a few times, that question, and I'll be honest, it doesn't really need to be found in the book, because if you remember the differences between extra low voltage and low voltage, and extra low voltage is up to 50 volts AC and 120 volts ripple free DC, you then realise that, okay, if I was to need basic protection on the terminals of my stationary battery, if I was to need to have insulation, I'd need to say, right, when is a battery becoming ELV to LV? And that's 120 volts. So you may have that question. It might give you voltages of 50 volts, 110 volts, 230 volts, 120 volts. The question simply says is, when do you now need basic protection on your stationary battery? When does it go from ELV to LV? Alright, but if highlight that if you feel that you need to. 552, rotating machines. All equipment, including cable of every circuit carrying the starting, accelerating and load current of the motor, will be suitable for a current at least equal to the full load current rating of the motor, when rated in accordance with the appropriate British standard. When the motor is intended for intermittent duty and for frequent starting and stopping, there will be account considered of any cumulative effects of starting or breaking currents upon the temperature rise of the equipment and the circuit. We have talked about that a little bit before, where we talked about braking of motors and considering the excessive thermal loading that will occur. 522.1.2, every electric motor having a rating that exceeds 0.37 kilowatts to 370 watts will require overload protection. And then the last bit there, except with failure to start after a brief interruption would be likely to cause a great danger, every motor will be provided with a means to prevent automatic restarting after a stoppage due to a drop in voltage or failure of supply, where unexpected restarting of this could potentially cause danger. Okay, so if you have a loss of supply and the motor starts to slow down and then it comes back on, this is what an undervoltage device would do. It would not reclose. It would actually stay open in case the restarting of the motor can cause harm or damage to equipment. .553 then. This is accessories, so this is just your simple accessories that you install. It starts with 553.1, plugs and socket outlets. Every plug and socket outlet will comply with the requirements of items 1 and 2 below, and in addition with the appropriate requirements of 553.12 and 553.22, or 553.12 to 553.22. Alright, so except for self circuits, it will not be possible for any pin of the plug to make contact with any live contact of its associated socket outlet, while any other pin of the plug is completely exposed. Okay. It will not be possible for any pin of the plug to make contact with any live contact of any socket outlet within the same installation other than the type of socket outlet for which the plug is designed. So yeah, if you think about that, your 13 amp plugs and then your 2 amps and your 5 amps and stuff, they can't go in with each other. That makes sense. Except for a cell circuit or a special circuit to 55315, every plug and socket outlet shall be of the non-reversible type, with provision for the connection of a protective conductor. So, I mean, with regards to polarity, I mean, our plugs, you can't really mistake that they go in one way and one way only. In some parts of Europe, some they have socket outlets that have actually two methods. Some will have an earth pin there, so that it has to be inserted in one way. Some actually don't, so you can have them unipolarly. It does depend really on the equipment, but over here we have it one way only. And again, the reason for that really is because we have a fuse in our cord set, because we have a fuse in our plug top, and that fuse must be in the line conductor and not the neutral. Five 55313. Except where 55315 applies in low voltage circuits, every plug and socket outlet shall conform with the applicable British standard listed in table 55.1. So you can see from that your 13 amp socket outlet is to BS1363, with fuses to BS1362. Every socket outlet for household and similar use shall be of the shuttered type, and for an AC installation, preferably be of a type complying with BS1363. It then goes on to talk about other types of sockets and they're being for a specific use. Shavers, clocks, and any other special requirements. Now 55316, this is something I've had to refer to quite a lot with heights. A socket outlet on a wall or similar structure will be mounted at a height above the floor or any working surface to minimise the risk of mechanical damage to the socket outlet or to an associated plug and its flexible cable, which might be caused during insertion, use or withdrawal of the plug. So I've seen a lot of discussion about heights of sockets, and I'm plugging this, I could just grab this over here. With regards to heights of sockets, as far as BS7671 is concerned, its only real concern is to ensure that the plug and the cord set don't get damaged. Now, in the case of this, take this cover off. In the case of this, you can see that there's a little cable grip there, and quite often, if you probably may see this in some hotels where they have sockets above a desk. Quite often they're mounted at a height where this grip is so low it doesn't actually allow it, and you end up having to force it like that, which is not suitable. It's not suitable for the actual plug. It's supposed to be a nice gentle thing. And I've known some hotel brands that I quite often stay in. They've in some of their refurbishments they're currently doing, they've had to put the sockets upside down, because the height that they've got them at is so low that people just can't plug stuff into them. As far as BS7671 is concerned, that's it. We must make sure that the height does not damage the plug or the cord set in simple utilisation. Now, there is a height requirement for new installations, and that's obviously the 450 to 1200, but that is from approved document M of the building regulations, and that's all about the users of the installation. These regulations are all about the actual safety of the equipment at this point. Where mobile equipment is likely to be used, provision shall be made so that the equipment can be fed from an adjacent and conveniently accessible socket outlet, with taking account of the length of flexible cable normally fitted to portable appliances and luminaires. There must be sufficient socket outlets in every installation. I remember I was at a bus station just recently, and there was a guy using Henry the Hoover, and his Henry the Hoover was plugged into an extension lead, which was plugged into another extension lead, which was then plugged into a socket, and it was just going across the floor with hundreds of people walking over it, and that wasn't really the issue that I'm talking about now. The issue I'm talking about right now is when he was using Henry the Hoover over near the entrances, there wasn't a controlled socket outlet that he could use, or something on a lock so that he could actually utilize it to clean the area without creating a huge trail of extension leads, which is, it's a trip hazard and it's a poor practice. Extension leads they're a temporary measure. If you actually look in the PAT testing code of practice, it does say in there that one of the things that a PAT tester is supposed to actually assess for is the quantity of socket outlets to ensure that there is a sufficient quantity. Alright, we then have cable couplers. And the cable coupler should be arranged so that the connector of the coupler is fitted at the end of the cable remote from the supply. And then we move on to current using equipment. Now, electrode water heaters and boilers. Every electrode water heater and electrode boiler will be connected to an AC system only and shall be selected and erected in accordance with the appropriate requirements of the section. The supply to the electrode water heater or electrode boiler shall be controlled by a linked circuit breaker arranged to disconnect the supply from all electrodes simultaneously, provided with an overcurrent protected device in each conductor feeding an electrode. Obviously, what we're talking about here with electrode water heaters isn't an immersion heater. This is where we actually have live probes within the tank, and electrolysis is being used to heat the water, so we'll pass current through. The earthing of the electrode water heater or electrode boiler shall comply with the requirements of Chapter 54, and in addition, the shell of the electrode water heater or electrode boiler shall be bonded to the metallic sheath of an armour, if any, of the incoming supply. The protected conductor shall be connected to the shell of the electrode water heater or electrode boiler and will comply with 543.1.1. Okay, so you can see here it's connected directly to the armour and to a CPC. When an electrode water heater or electrode boiler is directly connected to a supply at a voltage exceeding low voltage, the installation shall include an RCD arrangement to disconnect supply from the electrodes on the occurrence of a sustained earth leakage current in excess of 10% of the rated current of the electrode water heater or electrode boiler under normal conditions of operation. Except for, in any instance, a higher value is essential for stability of operation of the electrode water heater or electrode boiler. The value may be increased to a maximum of 15%. So we've got an illustration, and you can see this link, this link here between the neutral and the earth. This is needed so that the potential difference between from the line to the neutral is the same as from the line to the actual earthed chamber, so that none of this, bear in mind that this isn't to scale, it's to make sure that none of the current flows to earth and it actually goes to true neutral, true 0 volts. Here we have an insulated one, and you can see if it's an insulated one we still earth it, but we don't actually have to have this link. You can just see the layer of insulation there. It then has a bit of about 3-phase ones, but I won't go into that for too much. Go down to 554.4, heating conductors and cables. Where a heating cable is required to pass through or be in close proximity to material which it presents a fire hazard, the cable being close to material having the ignitability characteristics of P, as specified in BS 476-12, and shall be adequately protected from any mechanical damage reasonably foreseeable during installation and use. A heating cable intended for laying directly in the soil, concrete, cement, screed, or other material used for road and building construction must be capable of withstanding mechanical damage under conditions that can be reasonably be expected to prevail during its installation. It's during installation that this kind of thing is most vulnerable, because obviously once it's laid and it's down and it's done properly, it's fine. But whilst it's being installed, there's obviously lots more external factors and risks of impact and damage to it. It will be constructed of material that will be resistant to damage for the dampness and corrosion under normal conditions. Alright. Yeah, that's fine. 555 is short and sweet. That just basically tells us with auto transformers and step-up transformers, when auto transformer is connected to a circuit having a neutral conductor, then the common terminal of the winding is neutral. It will not be connected to an IT system, and a step-up transformer is used. A link switch will be provided for disconnecting the transformer from all live conductors of the supply. So, there's no 556 used in this standard yet, but 557 auxiliary circuits then. This section applies to auxiliary circuits except those covered by specific product or system standards. General. The power supply, being AC or DC for an auxiliary circuit, may be dependent or independent of the main circuit according to its required function. So it could be, you know, a dedicated auxiliary circuit, or it could be fed by the supply circuit. Control circuits. A control circuit shall be designed, arranged, or protected to limit dangers resulting from a fault between the control circuit and other conductive parts liable to cause malfunction of the controlled equipment. Okay, so I mean, there is a definition for auxiliary circuits if you're not familiar with it, but these are circuits designed to switch, control, limit, or vary the main circuit. So an auxiliary circuit is not a circuit doing work necessarily. It's not like carrying design current. It's a signal. It could be a simple like pulse. It could be a simple frequency. It could be a camera. It could be a solenoid. It could be a number of things. But it's all forms of switching and relays and things like that. Power supply for auxiliary circuits that are dependent on the main circuit. So these are dependent on the main circuit. Okay, so we obviously have a difference between DC and AC there. Now, the three examples given. We can have directly connected. So here we can see our live cables, and our auxiliary circuit is just taken off of it. So it's just like, you know, parallel fed off of it. Via a rectifier. Okay, so we have it again coming off, but it goes through a rectifier. Or via a transformer. So this will be just a simple mains, an AC mains powered auxiliary circuit. This would be an extra low voltage, maybe, or a 110 circuit, auxiliary circuit, and this is your DC. Now, when you're looking at if you do like work with control panels and things like that, quite often you'll see in there a number of relays or a number of inverters. What you'll often end up with, especially if you're working with PLCs, is you'll often end up with something like 12 volts or 24 volts. So you'll have the equipment in there, and then all of that cabling leaving there, going to all of the sensors, the limiters, the solenoids, and all that stuff will all be 12 or 24 volts DC most often. So there are three common methods to obtain an auxiliary circuit from the main circuit. If you had a question on this, just do remember that the rectifier is DC. That's referring to DC. It's recommended the auxiliary circuit supplying primarily electronic equipment or systems should not be supplied directly, but at least via simple separation from the main circuit. Okay. We have earth connections and auxiliary circuits there. And power supplies, standby supplies. AC supply, 50 Hz is 230 volts nominal, and 60 Hz is 277, and DC is 220. So those are the nominal voltages for the standby supplies, or for the auxiliary circuits, sorry. And you'll notice then we're kind of getting into a serious area where we're talking about protective measures, protection to the wiring system of auxiliary, short circuit, cross-sectional areas. If you're actually going to work with auxiliary control stations, you need to remember that they are themselves circuits, and so if dependent on what they're doing, I mean, in this case, they're carrying power. If an auxiliary circuit carries power, it may need to have its own separate protective measure consideration. It may need to have its own separate erection method, its own separate, protection against short circuit, so that's independent of the main circuit. Similarly, if you've got something that's going down to extra low voltage or DC, it's going to require segregation as well. So there are design requirements for auxiliary circuits, and if you think about that, if there are design requirements, there should also be commissioning requirements and testing requirements and certification requirements as well. Okay, there's a table there for sizes. Minimum cross-sectional area of the copper conductors in millimeters square. Control circuits, data transfer, etc. And then there's just more information. It's very, very wordy. I don't want to go through all of it. But if we go to... yeah, I think we'll just go on to 559 because it's all about auxiliary, but the auxiliary... It's just not worth putting too much time into it at this point. Let's go to 559. Luminaires and lighting installations. Yeah. Now, this is the selection and erection of luminaires and lighting installations tend to be part of the fixed installation. It's got a little scope on it. It does not apply to high voltage signs. It does not apply to signs of luminous discharge tube installations. It does say in Note 1, outdoor lighting installations, extra low voltage lighting installations, and lighting in special locations are in Part 7. They did that quite recently, actually. They took outdoor lighting and self and pelv lighting. They took that into Part 7. General requirements then. Every luminaire will comply with the relevant product standard for manufacture. And for the purposes of this section, a luminaire without transformers or converters which are fitted with extra low voltage lamps connected in series to a low voltage supply shall be considered as a low voltage equipment, not extra low voltage equipment. Makes sense. You're actually utilising it on low voltage. A luminaire in a pelmet with no adverse effects due to the presence of operation of the curtain or blinds. Okay. We'll see some symbols coming up in a minute. We go to 559.4. Thermal effects. In the selection and erection of a luminaire, the thermal effects of radiant and convected energy on the surroundings will be taken into account, including the maximum permissible power dissipated by the lamp, the fire resistance of adjacent material, the minimum distance to combustible material, and the relevant markings on the luminaire. So we've got to remember that obviously lighting gives off heat, especially, well, we're going down the LED market a lot now, but we still do use incandescent lighting a lot of the times with other areas of lighting. So we've always got to be aware of the heat that is accumulated from lighting and the combustible materials that are around them. Whenever you purchase a luminaire, the manufacturer's instructions must be followed, and those will dictate a clearance of the luminaire from the combustible materials around them. We have specific methods of connection to the fixed wiring between the luminaire and that, and those are given in 55951. Okay, all the British standards of the recognised connection methods. It then has in .201, 559.5.1.201, a ceiling rose or lamp holder will not be installed in any circuit operating at a voltage normally exceeding 250 volts. A ceiling shall not be used for the attachment of more than one outgoing flex unless it's been designed to do that. So when you have a ceiling rose, you'll have one flex in your ceiling rose, not two. That makes sense. Luminaire support couplers and devices for the connection of the luminaires are designed specifically for the electrical connection of the luminaires and won't be used for any other equipment. So do not wire a heater onto a light circuit through a luminaire support coupler. Light circuits incorporating B15, B22, E14, E27 or E40 lamp holders must be protected by an overcurrent device not exceeding 16 amp. Bayonet lamp holders B15 and B22 will be of temperature rating T2. And with regards to polarity, 206 in a circuit of a TN or a TT system, unless it's an E14 or E27 lamp holder, we must ensure that with the Edison screw lamp holder, the center contact is line and the thread is neutral. Lighting installation shall be appropriately controlled. And consideration should be given to the provision of the neutral conductor at each switch position to facilitate electronic switching devices. So we've said a number of times we don't switch neutral, we mustn't switch neutral as a single pole method of switching. We've had this common thing for years where we just never would take neutrals to switches, but they're now starting to say that it might need to be, with electronic switching, that neutrals may need to be considered at light switches. Fixings of luminaires. Adequate means of fixings will be provided. We'll consider the mechanical accessories, boxes or enclosures which are able to support the luminaire. In a place where the fixing means is intended to support a luminaire, the fixing means will be capable of carrying a mass not less than 5 kilograms. If the luminaire is more than that, then we're going to find a better means of fixing, so anchors and chains and things like that. Through wiring. The installation of through wiring in a luminaire is only permitted if the luminaire is designed for such wiring. So this is an example where you have like a long corridor or a long alleyway, and you'll have tubes that are going long ways down, and you'll take the conduit in one end and you go out the other end. The luminaire may not allow the cabling to travel through it. Yeah, quite often a manufacturer will say cable entry here, and it will have a termination there, and it will not intend for you to take the cabling beyond that point. If the manufacturer allows for it, they'll probably apply some heat-proof sheathing or a metal heat sink that goes next to a ballast or a choke or any other component that heats up within the luminaire. Okay, groups of luminaires. Groups of luminaires divided between the line conductors of a polyphase circuit with only one common neutral conductor shall provide with at least one device disconnecting simultaneously all line conductors. That's a common question, that one. All line conductors must be done by one device at one point. UV radiation, ballasts, compensation capacitors. It mentions there half of a microfarad will be required. Yeah. That's fine. And then right at the end it mentions ground recessed luminaires, which is a new part to the 18th edition, but it actually just says go and buy another standard and read it. It's not very useful information there at all. It just says go fish, basically. And then at the last page there you've got this table which I showed you here, which is just the symbols used in luminaires with regards to temperature rating, sodiums, high pressure sodiums, the surfaces they could be mounted on, the independent ballasts, etc. Have a little review of those and you'll be fine. Okay, so that was chapter 55. Low voltage generating sets, rotating machines, accessories, electrical equipment, or water electrode and boilers and things, auxiliary circuits, and last of all, luminaires and lighting installations. We're nearly done with part 5. We've got one more thing to consider. So up to now, we've talked about selection erection we've talked about the common rules, selection erection of wiring systems, cable selection. We've talked about reference methods. We've then talked about devices for isolation, switching, monitoring, protection. We've then talked about earthing and the protective conductor requirements. We used the adiabatic. Then in this video we've talked about other equipment, low voltage generating sets, luminaires, accessories, rotating machines, etc, etc. So what else is there that we need to think about? Well, just one little bit, which is going to be chapter 56. I'll do another little video on that one, and this is simply just your safety services, really. Let me just get there. So it'll actually be very, very short, which will be nice. So we'll talk about the need for safety services, the sources for safety services, and supplemented standards as that. So it's kind of like an add-on part to part 5, but we'll do that, and that will actually finish off part 5 in the next video. So yeah, I'll see you in chapter 56 next.